Okay, so we're getting ready for the next test. There's a problem like this on your exam review. What I want to do here is I'd like you to go ahead and hit pause, work through this problem. I'm going to send you a doc version that has these answers. Try to do this and then go ahead and hit play and see if you did this the same way I did. So what we're going to do here is to find the percent remaining. There was 850 when we started. There's 553 pips of the candy after the first hour. So 553 divided by 850 is 0.6505. And then I'll times by 100 and I get 65.06%. Let's just round to the nearest. Round one decimal place. That's what it tells us. So 65.1%. Now, we're going to, again, do a similar thing here, but we're going to take hour number one, which was 553, and divide that by the current amount remaining, which is 409. So 409 divided by 553, and then that gives me 0.3796. If we round this one decimal place, it's going to be, I'm going to write this out. So if I times this by 100, I get 73.96. Rounded one decimal place, this is actually going to round up to 74%. This one we will do 335 over 409 and times 100. I get 81.9%. All right, I'm going to hit pause right here. Go ahead and fill in the rest, and we'll check in a second. Okay, so I went ahead and completed those. Take a look, make sure you get the same thing I did. Might be a chance that I made a mistake. If there is, email me, let me know. So anyway, we got these worked out. One thing I want to state to you guys, make sure you're showing a little bit of work on the test. Again, this just lets me know where those percentage came from. Next question, explain why the NA is the first cell in the percent remaining column, and the reason is because 0, well, think about it. There is no percent remaining after, this is the initial time, right? So there was no previous. Calculate the average percent remaining value. Whoops, I need to make some room for myself here. So to do this, I'm just going to average those up. So it's going to be, that's right, what we're going to do, we're going to add the values and we're going to divide by 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to add those up. Just double check and make sure I got everything in here. 77.1, 75.3. So I get 673.2 over 9 gives me 74.8% is the average. So we can expect about 74.8% of whatever was before. So using the value from part C, estimate the amounts remaining after 10 hours, 11 hours, and 12 hours. Well, at 9 hours, there were 64, right? So let's just say 9 hours. It's going to be 64. And then we're going to multiply that by, well, about on average, there is 0.748 or 74.8% remaining. So 64 times 0.748 gives us 47.82. We'll round this to the nearest whole number, and we'll say that this is 48 rounded. The 10th hour, well, there are 48 remaining after hour 9, so take 74.8% of that. gets me to 35.9, which will round up to 36, main rounded. And our 11. Oh, sorry. So this would be our 10. This would be our 11. Then we'll do this one more time for our 12. And that would be 36 times 0.748, which gives us 26.9, which we'll say 27. Okay. Using the value from part C, write an exponential model for this data. Explain what each of the values mean in the problem. Cleaning up that last one. All right, so exponential equations follow the form y is equal to a times x, times r to the x. So our initial amount of candy was 850. So that's going to be here. So we're going to put the 850 for A. The average rate, on average, there's 74.8% or 0.748% remaining after each hour. And then this y value is going to be the amount of candy. So we want to also say what these represent. Y is the amount of candy after X hours. So if I put a 2 up there, that'll tell me how much candy is after 2 hours, or 10, how much there's after 10 hours. 850, this is the initial amount of candies. .748 is average percent of candy that remains after each hour. And then our X value is how long or how many hours the candy has been sitting out. So it's important not just to say something like, this is the rate, this is the initial amount. Initial amount of what? Initial amount of candy. X is the amount of hours the candy's been sitting out. So really put this into the context of the problem. And then the last one. I want to refill the candy bowl when it's half full. Using the equation from E, give the number, not number of hours rounded to the nearest tenth for when I will need to refill the bowl. So half the candy would be, well, I have 850 to start with. Half of that is 425. We're going to use this exponential equation. Y is equal to 850 times 0.748 raised to the x power. And we're just going to plug in some numbers until we evaluate. So we can kind of go back and look up at our data and we can see, okay, 425, that was somewhere between hour 2 and 3. So let's check hour 2. Now, our equation is not going to do exactly what the table showed us, but let's just start and say 2 hours. And that will give us 850 times 0.748 to the second power. And that gives us 475 pieces of candy. Well, 476 rounded. That's too high, right? Let's try 3 hours. 850 times 0.748 to the third power. When I evaluate this, this tells me it's 355 pieces. Well, that's too low. All right, so it's somewhere between 2 and 3. Notice we have to round to the nearest tenth, so we need 1 decimal. Let's say 2.5 hours. 850, 0.748, 2.5. I get 411. We want 425, right? That's too low. We're really just picking values. We're just testing. I think there's more candy as the less time goes by, so I got to get closer to 2. So we're going to pick something like 2 point, I don't know, let's go with 2.3 hours. I know this feels kind of tedious, but we're just going to test these values till we get close enough. All right, 2.3. That gives us 435 pieces. Let's do 2.4. And when I test 2.4, I get 423.4. So 2.5 was too low. 2.3 was too high. This 2.4 feels like it's just right. You always want to check the value above and below to make sure you are at the right spot, because even if you get something that's close, there might be one that's closer. So really all we're doing here is we're picking and testing a set of values until we get one that's close enough for us to identify that, okay, refill it after, let's answer the questions. Refill after 2.4 hours.